In this video, we're finding the area between two functions. We have y equals 2x squared minus 8x plus 9, and y equals 6 minus x. Y equals 2x squared minus 8x plus 9 is a tight parabola opening upward. And then we have y equals 6 minus x, a line that has y and x intercepts of 6. So you see that the line crosses the parabola, and you have this area that's bound in between that we're going to find the total area of using integrals. Now in this particular problem, this example, we don't have it stated ahead of time what the limits of integration are. But the limits of integration are going to be the values of x at which the two functions cross. So what we need to do is we need to find those limits of integration. So in order to find those limits of integration, we're going to go ahead and set the two functions equal to each other. 2x squared minus 8x plus 9. And we're going to set that equal to 6 minus x. And determine the values at which the two functions are equal. So, doing a little bit of basic algebra. So we add the 6, so we have minus 7x. And subtract the 6, we have plus 3 equal to 0. Factor that, we get 2x, x. And factoring that, we have the two values of x equals 1/2 and x equals 3. Now another aspect to consider is which of the two functions are actually the larger of the two functions, because we want to find the integral of the larger function minus the smaller function. So again, we're considering what all elements in between the two curves with a thickness of dx, the height times the width is going to look like. From a to b, which we determine are from 1/2 to 3. Now we can see from the picture that 6 minus x is clearly the larger one. But if you don't see that right off, or you don't actually have a picture of the graph, you can always check that by picking a value that's clearly within the limits of integration. So for instance, at x equal 1, just to pick a simple value, substituting 1 into that, it looks like we're going to get 3. And then substituting 1 into 6 minus x, it looks like we're going to get 5. So in between those, we're shown that actually 6 minus x is the larger of the two, just by testing a value somewhere within that interval. So we're ready to set up our integral and solve to find the area. So the limits of integration are 1/2 to 3. The larger function is 6 minus x. The lower function is 2x squared minus 8x plus 9. Again, the larger minus the smaller. However, in order to just make things a little bit simpler, you might want to go ahead and simplify this integral a little bit. So you could, of course, integrate at the step you are at there, but let's go ahead and simplify this. Negative 2x squared, and it looks like we're going to have plus 7x, and then 6 minus the 9 minus 3 dx. And then now we're ready to actually integrate this function. So negative 2/3 x to the third plus 7/2 x squared minus 3x, evaluated from 1/2 to 3. Okay, substituting 3 and then simplifying the fraction, we're going to get 9/2 as the value at 3, the upper limit of integration. And then we subtract the value at the lower limit of integration at 1/2. And as a simplified fraction, we could get by hand or through the calculator negative 17 over 24. And then adding these together, we're going to arrive at 125 over 24, which is just a little bit more than 5. As a reduced fraction, our area bound between the two curves.